Hello guys, welcome back to my channel RG Structure. In today's video, we are going to solve another sample problems of cantilever beam deflections. So as you can see here in the figure, we have a cantilever beam 14 feet long and loaded with uniformly distributed load of 72 pounds per foot and a concentrated load at the tip of the beam of 800 pounds. And we are giving the value of EI, which is 5 times 10 to the power of 10 pounds, that's square inch. So we have here the formula because the deflections at the tip, they are at one location at the end, so the maximum deflection is at the tip of the beam. And if we separate the load P, the formula of maximum deflections when the cantilever beam is loaded with the load P, concentrated load, we have the formula of PL cube over 3EI. And the uniformly distributed load, we have the formula of WL to the fourth over 8EI. So if you just if you want to get the maximum deflection here at the tip, you just combine these two formula. So just for reference guys, I'll show you where to get this formula. So if you have that EIEC book, you can find the uniformly distributed load. We have this cantilever uniformly distributed load, table 3-23, 14th edition EIEC. So this is the formula, WL to the 4th over 8EI. This is the formula of uniformly loaded beam cantilever. So for the concentrated load, you can find it here at table 3-23. Concentrated load at the tip, we have this formula PL cube over 3EI. So that is the formula of this cantilever beam. So the solution for this, we'll just convert the uniformly load to 72 pounds per foot to inches to be consistent with our unit, and the L span is 14 feet, so that is equivalent to 168 inches. So the total maximum deflection of the beam at the tip is just to add this deflection due to the load P, which is this one, plus the deflection due to the uniform load W and this formula. So if we evaluate the deflection due to delta P, we have 800 pounds times 168 to the power of 3 all over 3 times 5 times 10 to the power of 10 40 square inch, and that would give us 0.0253 inches. That is the deflection due to load P alone. So the next deflection is to find the deflection of this formula due to the uniform load, that is WL to the fourth over 8EI. This is supposed to be W. So the formula is 6 times 6 pounds times 168 to the power of 4 divided by 8 times 5 times 10 to the power of 10, and that is the flexural rigidity, equal to 0.012 inches. So if you add that maximum deflection H of this load, that will give us 0.0253 plus 0.012, and that is a total of 0.0372. So that is the maximum deflection at the tip of the cantilever beam. So that's conclude our problems, the solution of our problem. So thank you guys. Thank you for watching. And if you find this video helpful, please don't forget to like and subscribe. See you next time. Bye bye.